Okay, we're at 9-3, solving rational equations. I've got two examples, one simple, one a little bit more complex, similar to what I expect you to be able to do. It's not really that hard. I guess we need a plus sign right there. It's not that hard if you understand the basic rules of fractions, then apply that concept to things like variables. All right? So if you have a simpler problem like this, we need to get rid of these fractions. And so I'm going to show you a technique that's called clearing the fractions. It's pretty straightforward, pretty simple. It does basically the combining then the cross multiplying all at once that you may have seen us do earlier. So I look at these numbers below and I ask, are they relatively prime, or does one go into the other? 2 doesn't go into 7, 3 doesn't, nothing works. So I'm going to multiply all of these by the lowest number that has all of them, which is in fact the product of those three numbers. So I'm going to multiply all of them. I'll go to a different color here if I can. I'm going to go and multiply all of them by 3 times 7 times 2. Now I could multiply that all together to make 42 and multiply each by 42, but then I'll just be canceling back down anyway, so there's no point in doing that. So I'm going to write 3 times 7 times 2 for each of these. 3 times 7 times 2. Each term gets multiplied by that. If you are new at doing this and not so confident, you can write it all 3 times. If you're a little bit better, you write it once and then you just know to carry it out to all 3. Here though, the 3 cancels with the 3. 7 times 2 is 14, then times x. Plus, here the 7 cancels with the 7. 3 times 2 is 6, times 2 is 12, and then remember the x. Then here the 2 cancels and I get this equal to 21. Well, if I solve this, this now becomes a ridiculously easy problem. It's just 26x equals 21. 26, I divide that, and I say x equals 21 over 26. Okay? So very simple to do. We're going to apply the same concept down here to this one. I look at these, and it's harder with variables to know if they're relatively prime, but you can't divide this into that. The question is, that's a quadratic, and you always have to consider if you can factor that. Well, this does in fact factor to be x plus 1 times x minus 2. If you're not good at factoring, you can check that out in another video. But if you factor it, you'll see that these are in fact contained here in each of these. It's like if we had had a 6 here. If that had been a 6, 3 goes into 6 and 2 goes into 6. So I wouldn't have to multiply by 3 times 6 by 2, I could just simply multiply by 3 times 2 and they would cancel. So I'm going to multiply by these all the way across the board. So that's going to be x plus 1 times x minus 2, x plus 1 and x minus 2, and finally the same thing, x plus 1 plus 1 and minus 2. I'm going too fast. Alright, so same rules apply. Here this cancels with that and I get 3 times x plus 1. Plus, here the x plus 1 cancels with the x plus 1, and look, the x minus 2 cancels with the x minus 2 and I get plus 2. These become just 1, so 2 times 1 over 1 is just 2. And then here the x plus 1's cancel and I get 7 times x minus 2. So when you get to this stage, just very carefully distribute, and I'll get 3x when I bring that into each, plus 3 plus 2 equals, bring those into each, 7x minus 14. Just make sure you gather up your x's and your numbers. Subtract 3x from both sides and I get 4x. Add 14 to my 2 and 3, which make 5, and I get 19. So 19 divided by 4 equals x. Okay? Check that out, see if that's the correct solution. Thanks.